Okay, now that we know how to identify all 6 trig functions using the unit circle, what I want to do now is I want to move forward where we're going to try and identify the 6 trig ratios of coterminal angles. You remember coterminal angles. Remember we said that we don't have to go just from 0 around to 2 pi, right? We can actually go backwards. If this is 0, instead of moving this direction, we can actually start here and move backwards, and the angles become negative angles. Okay? And that's the great thing about the unit circle. It allows us to answer theoretical angle questions, whereas just a regular triangle fails in that area. So we can go from 0 and go backwards, and this then becomes negative pi over 6. This becomes negative pi over 4, negative pi over 3, negative pi over 2. Basically, the way you handle the negative angles is you go the vertical, you take whichever angle is up here, vertically go straight down, and that angle becomes negative down here. So this is pi over 6. You go vertically down, this is now negative pi over 6. Here's pi over 4. Go vertically down, this is now negative pi over 4. So when you're doing negatives, so over here, this is going to be the negative of whatever is normally up here. Normally up here we have 2 pi over 3, so that means this one is negative 2 pi over 3, right? So we can go negative, and we can keep going around and around. We've already seen how you can have, like, for example, probably like negative 73 pi over 6, and then there's a way to convert that into an angle that is on the normal unit circle, right? Similarly, once we get around here to 11 pi over 6 and then 2 pi, we can just keep going. This then becomes 13 pi over 6. This then becomes 9 pi over 4. And this one becomes 7 pi over 3. And then we keep climbing around to 2 pi, or excuse me, to 4 pi. Then 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, etc. Okay? So we know that we can just keep going around the unit circle either in a forward direction or in a backward direction. Okay? Forward is always counterclockwise, backward is always clockwise. Okay? So we know that we can do this, and we learned that the way we identify the coterminal angle is either by, if we take a negative angle, we can add 2 pi repeatedly, okay, until the theta angle is between 0 and 2 pi, right? This is for a negative angle, okay? For a negative angle. But for a positive angle, for a positive angle that is greater than, let's say, that is greater than 2 pi, okay? So if we have, like, 17 pi over 3, what we do is we subtract 2 pi repeatedly. You've already done this, so we're just reviewing. You subtract 2 pi repeatedly until your angle, your theta angle, is between 0 and 2 pi, okay? And so here's what I want to do. Is I want to, here's some examples, is I want to identify trig functions for theta angle measures that are not between 0 and 2 pi. So our first example is going to be 29 pi over 6. We're going to identify sine, cosine, tangent, cotangent, secant, and cosecant of 29 pi over 6, okay? And we're going to do it using the unit circle. But as you can see, this unit circle has not been filled in yet. So what I thought we would do is, our first exercise for this lesson can be, you can get out a blank sheet of paper, put a circle on it, Put a x-axis, a y-axis, put your 16 dots on it. And what we'll do is we'll start off with writing out a unit circle that we can now use for today's lesson. Okay, so pause the video and go. Okay, now hopefully you were able to get the whole thing done. By now you should be able to complete a unit circle without looking at any notes. Nonetheless, I'm going to go ahead and fill one out now. You may think, oh, you know, Mr. Ryan, you think you're so tough. Maybe you forgot how to do a unit circle. Well, I guess that's possible. Well, let's find out. Okay, let me do my best to try and fill out a unit circle. I know that this is 0. It's also 2 pi. I know that over here we have pi. I know at the top of the circle is pi over 2. And at the bottom of the circle is 3 pi over 2. I know over here in this first quadrant we have, well, this is pi over 2. This is pi over 3. This is pi over 4. And then this one's pi over 6. Good. Now coming over this way, I know that this one's going to be over 3, right? This one's going to be over 4. This one's going to be over 6. I know that this one's going to be over 6. This one's also over 4. And this one's over 3. I know that this one over here is going to be over 3. This one's going to be over 4. And this one's going to be over 6. Okay? Over in this one, I've got 1/3, 2/3. So that's 2 pi over 3. Or I can subtract 1 from the denominator and I get the number in the numerator. So I'm going to subtract 1 from 4 to get 3. That makes this 3 pi over 4, or 3/4 of pi. We can also say it's 3/4 pi because we have 1/4, 2/4, 3/4 of pi. Okay? Here this is going to be 5 pi over 6. This one down here is 7 pi over 6. This one is 5 pi over 4. This one is 4 pi over 3. Coming over here, we got 5 pi over 3, 7 pi over 4, and 11 pi over 6. Okay, I'm halfway done. I know I got these right. I've got all my angle measures. Now I need my coordinates. Well, I'm going to do the easy ones first. I know that this one is 1, 0. And I know this one up here is 0, 1. And this one over here is -1, 0. And this one down here is 0, -1. Good. Now I'm going to do the more difficult ones. I know that the over 4s are the same on both. And it's square root of 2 over 2, square root of 2 over 2. So I know that this one over here is the same thing, only it's negative square root of 2 over 2 and positive square root of 2 over 2. This 5 pi over 4, that's the same thing, only they're both negative this time. Negative square root of 2 over 2, negative square root of 2 over 2. And then this one over 4 is positive x and then negative y, right? So square root of 2 over 2, comma, negative square root of 2 over 2. Now let's work on these. Now I know that this one has the same coordinates as this one, only they're flipped around, right? And the way I remember it is that this point is closer to 1 than this point, okay? This one comes first, that one's here, and then this one is here, right? And so this one, the x value must be larger than the x value on this one, right? And therefore, it's either square root of 3 over 2 or it's 1/2. And so square root of 3 over 2 is larger, so the x-coordinate here is square root of 3 over 2, where the x-coordinate on this one is 1/2. And so now that means that the height of this one must be 1/2 because I know that the coordinates reverse. And to prove that this one's 1/2, the y value is 1/2, you can see going up, we hit this one first, and then we hit this one second. So this one must be higher than this one, and square root of 3 over 2 is higher than 1/2, okay? And so now we've got our coordinates up here. So this one reflects over here. Except that the 1/2 is negative. So we'll have negative 1/2, comma, square root of 3 over 2. This one is going to reflect over to this one, only the square root of 3 over 2 is going to be negative square root of 3 over 2 and 1/2, okay? Then we're going to come down here. This over 6 is going to be the same as the over 6. It's going to be square root of 3 over 2 and then 1/2, but they're both negative. So this one is going to be negative square root of 3 over 2 and negative 1/2. The over 3 is reversed, but they're still both negative. So we're going to have negative 1/2, comma, negative square root of 3 over 2. Put the parentheses there. Last couple here. Over 3 is the same as this over 3. The 1/2 comes first, but the y value is negative. Negative square root of 3 over 2. And then on this one, it's the same as the pi over 6. This is 11 pi over 6. This is pi over 6. Same coordinates, except the y is going to be negative. And so we're going to have square root of 3 over 2, comma, negative 1/2. And there is our unit circle. Hopefully you got all these same numbers, okay? All right, now that we understand that, let's now talk about how we answer a question like this. Sine of 29 pi over 6. Well, basically, we're going to do the same thing that we did before with coterminal angles, is we're either going to add 2 pi or subtract 2 pi. And so I want to subtract 2 pi from 29 pi over 6, because here's what I want to do is I want to know which one of these angle measures is going to match up with 29 pi over 6 as a coterminal angle. Okay? Now, it is over 6. So what that basically means is it's either going to be pi over 6, or 5 pi over 6, or 7 pi over 6, or 11 pi over 6, because it's already over 6. Now, if it was an even number over 6, if it was 30 over 6, then I could divide the top and the bottom by 2, and then it would make over 3. And then I would know that it was related to pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. But we cannot reduce this fraction. Once the fraction is to the point where it can't be reduced anymore, that's its final denominator, okay? Now, one of the tricks that I taught you was that one way that you can add 2 pi or subtract 2 pi is by doing this. You can double the denominator and then add that number, the doubled denominator, to the coefficient of pi in the numerator. So here's what I mean. Let's look at coterminal angles on the unit circle. Going around the unit circle, we have pi over 6, pi over 4, pi over 3, pi over 2, etc., all the way around to 11 pi over 6 and then 2 pi. If we keep going around the unit circle, okay, going from here, from 2 pi, I want to know what this angle is now going to be after we pass up 2 pi. And the way we're going to do that is we're going to double the denominator. We're going to double 6. That's 12. We're going to add 12 to the 1 that's in front of the pi. 12 plus 1 is 13. And therefore, this point is coterminal to 13 pi over 6. We can do the same thing at pi over 4. Double the denominator. 4 times 2 is 8. Add it to the 1 up here. That's 9. So that means this is the same thing as 9 pi over 4. We can do the same thing here. Double the denominator. 3 times 2 is 6. Add 1 is 7. So this is the same thing as 7 pi over 3. At the pi over 2, double the denominator. 2 times 2 is 4, plus the 1 up here is 5. So this is the same as 5 pi over 2. Let me stop there just for a second and show you something. So this is pi over 2, 2 pi over 2, which is just pi, 3 pi over 2, 4 pi over 2, which is 2 pi, then 5 pi over 2. And we can continue doing the same thing at the half. 5, 6, 7 pi over 2, 8, 9 pi over 2, 10, 11 pi over 2, 12, 13 pi over 2. And I hope you notice that at this point and this point down here, it's always an odd number, an odd coefficient to the pi. And over here, it's always a non-fraction. So what we do here is this is 0, then pi, then 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, etc., etc., all the way on to infinity. I mean, we can have 4,923 pi, and because it's an odd pi, it would be over here. All the even pi's are over here. All the odd pi's are over here. Okay? All right, so let's come over here. we're going to double the 3. 3 times 2 is 6, plus 2 is 8. So this is the same thing as 8 pi over 3. This one, 4 times 2 is 8, plus 3 is 11. So this is the same thing as 11 pi over 4 over here. 6 times 2 is 12. 12 plus 5 is 17. This is the same thing as 17 pi over 6. And then this would become 3 pi. Okay? Down here, 6 times 2 is 12, plus 7 is 19. So this is the same thing as 19 pi over 6. Double 4, that's 8. 8 plus 5 is 13. So this is the same thing as 13 pi over 4. I say same thing to mean coterminal. Okay? All right, so 4 pi over 3. 3 times 2 is 6, plus 4 is 10. So this is coterminal to 10 pi over 3. This is 2 times 2 is 4, plus 3 is 7, so 7 pi over 2. 3 times 2 is 6, plus 5 is 11, so this is 11 pi over 3. 4 times 2 is 8, plus 7 is 15, so this is 15 pi over 4. 6 times 2 is 12, plus 11, so this is 23 pi over 6, okay? And so now, 2 pi plus 2 pi, that's 4 pi. There we go. So we have just gone one more round and identified a bunch of angles that are coterminal to our regular angles on the unit circle. Okay. Now we didn't run into 29 pi over 6, so that must mean that 29 pi over 6 is either on the third round or fourth round or fifth round. Okay. But in my opinion, you shouldn't have to keep writing these angles on the unit circle. All you really have to do is take your 29 pi over 6 and then subtract 2 pi. Now again, remember the way I said you get 2 pi is you multiply the 6 times 2, that gives you 12 pi over 6, right? 12 pi over 6, 12 divided by 6 is 2. So this is 2 pi. 29 pi over 6 minus 12 pi over 6 is 17 pi over 6. That's not one of our normal ones. Although look, it's right here, 17 pi over 6. So it must be 5 pi over 6. But what we would do to get to 5 pi over 6 is we now have to subtract another 12 pi over 6. And 17 pi minus 12 pi is 5 pi. So this is 5 pi over 6. So now we know that identifying the 6 trig ratios of 29 pi over 6 is the exact same thing as identifying the 6 trig ratios of 5 pi over 6. And so you can just pretend that in the parentheses here that you're seeing 5 pi over 6. So now, if we're going to identify all of the trig ratios, the first two that we need are sine and cosine. Do you recall that cosine is the x-coordinate of the coordinate of the point on the unit circle, and the sine is the y-coordinate of that point, okay? So what that means is that sine of 29 pi over 6 is the same thing as sine of 5 pi over 6, and sine of 5 pi over 6 has a y-coordinate of 1/2. Therefore, sine of 29 pi over 6 is also 1/2. Cosine of 29 pi over 6 is the x-coordinate of 5 pi over 6, which is negative square root of 3 over 2. So negative square root of 3 over 2. And now we can answer tangent, cotangent, secant, and cosecant just by knowing sine and cosine and using they're called identities is what they're called, and using the identities for them. Okay, so let's go ahead and identify tangent. Tangent of 29 pi over 6 is the same as tangent of 5 pi over 6. Tangent is sine over cosine. Sine is 1/2 over cosine is square root of 3 over 2, right? Remember how we said in the last video that you can, if the denominator and the numerator and the denominator and the denominator, if they're the same, you can just cancel them out. And so what we now have is 1 over the square root of 3, but we want to rationalize the denominator, so we're going to multiply by square root of 3 over square root of 3, and we ultimately get the square root of 3 over 3. And so that is the tangent of 29 pi over 6. So square root of 3 over 3. Good. Now we would need cotangent. Well, cotangent is the reciprocal of tangent. And so it's cosine over sine, right? And so we're going to put cosine, square root of 3 over 2, in the numerator, and sine, 1 over 2, whoops, that was negative 3 over 2. Oh, you should have told me. Why didn't you tell me? Hang on a second here. Actually, we'll come back to this. We'll leave this here. This is negative square root of 3 over 2. Really, all it's going to do to this is it's going to make it negative. It's still going to be the same value. But just so we make sure, it's sine over cosine, right? Cancel the 2's. Now we get negative 1 over the square root of 3, multiply by square root of 3 over the square root of 3, and we wind up with negative square root of 3 over 3. Okay? Sorry about that, folks. Yep, I make mistakes all the time. Okay, so now, for cotangent, we're going to put cosine in the numerator, which is negative square root of 3 over 2, and sine in the denominator, which is 1/2. We're going to cancel the 2's, and what we wind up with is negative square root of 3 over 1, which is just negative square root of 3. Excellent. Okay, so the answer to this is negative square root of 3. Okay? All right, for secant, we're going to do 1 over cosine of theta. Okay, so 1 over, and cosine is negative square root of 3 over 2, right? Now, remember that 1 over a fraction, if it's 1 over the fraction, then that means the reciprocal. So we can just flip over negative square root of 3 over 2, which becomes negative 2 over the square root of 3. But now we have a radical in the denominator, so we're going to multiply by square root of 3 over the square root of 3. 2 times square root, well, negative 2 times square root of 3 is negative 2 square root of 3 over square root of 3 times square root of 3 is 3. And so our answer is negative 2 square root of 3 over 3. Negative 2 square root of 3 over 3. Last one. Cosecant of 29 pi over 6 is the same thing as cosecant of 5 pi over 6. And cosecant is 1 over sine. Okay? And in this case, sine is 1/2. So that's 1 divided by 1/2. Well, 1 divided by 1/2, 1/2 goes into 1 twice. So the answer is just 2. And so cosecant of 29 pi over 6 is 2. Okay? All right, now let's do one where the theta angle is negative. So we started at 0, and instead of moving forward, we moved backwards. So now let's try and identify our 6 trig ratios only with a negative theta angle. Okay, so what we've got here is we're looking for sine, cosine, tangent, etc. of negative 17 pi over 4. Negative 17 pi over 4. Okay, well, let's see what it looks like for the coterminal angles in the negative. Okay, so if we start here and go backwards instead, what we're doing is we're going from here to here the same distance that we would be going from here to here, only in a negative direction. So going from here to here gives us negative pi over 6. Okay, so this is negative pi over 6. Now, one way you can do that is you can double the denominator, so 6 times 2 is 12, and subtract it from the coefficient of pi. So 11 minus 12 is negative 1, or negative pi over 6. All right, same thing here. We're going to double the 4. That gives us 8. 7 minus 8 is negative 1. So this one's going to become negative pi over 4. This one, double the 3, becomes 6. 5 minus 6 is negative 1. So this one becomes negative pi over 3. And over here, we're going to double the denominator. 4, 3 minus 4 is negative 1, so this becomes negative pi over 2. Now you can see that these angle measures, pi over 6, pi over 4, pi over 3, pi over 2, are the same exact angle measures as up here. Pi over 6, pi over 4, pi over 3, pi over 2, only vertically they're reflected across the x-axis, and they're down here, and now they are negative, okay? And therefore, because this one is 2 pi over 3, this one down here is going to be negative 2 pi over 3. Okay? But don't take my word for it. Let's just, well, actually, yes, please take my word. I'm the teacher. I'm not lying to you. But still, nonetheless, let's just check. We're going to double the 3, gives us 6. 4 minus 6 is negative 2. Sure enough. Let's bring the 3 pi over 4 down here and make it negative 3 pi over 4. Okay? If we double the 4, that's 8. 5 minus 8 is negative 3. Okay, good. We're going to bring this down as negative 5 pi over 6. Negative 5 pi over 6. Double the 6 makes 12. 7 minus 12 is negative 5. Now here we can't reverse, right? Here there's no reflection across the y-axis. Well, guess what? This one is actually, it's the same thing as this one, only negative. Pi, if you subtract 2 pi from pi, pi minus 2 pi is negative pi. And so this point here is both pi and it's negative pi. Okay? So this 5 pi over 6 is going to be this one down here, only reflected up here as a negative. Okay? So 7 pi over 6 becomes negative 7 pi over 6. This one becomes negative 5 pi over 4, and this one becomes negative 4 pi over 3. This one becomes negative 3 pi over 2, and I can prove it to you. 2 times 2 is 4. 1 minus 4 is negative 3. That's negative 3 pi over 2. So negative 3 pi over 2. This one becomes the 5 pi over 3, only negative, so this is negative 5 pi over 3. This one becomes the 7 pi over 4, only negative 7 pi over 4. And this one becomes 11 pi over 6, only negative 11 pi over 6. And then this 0 becomes negative 2 pi. Okay? And so it goes from 0 and it goes backwards, negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 3 pi over 4, etc., until we get to negative 2 pi. Now, we can then continue from negative 2 pi. And so on the next rotation around, the second rotation around, backwards from 0, would then become, we would have to double the 6, becomes 12. We got a negative 1 here, minus 12 is negative 13 pi over 6. Now, I'm not going to go through all of them, but I want to show you something. Wasn't 13 pi over 6 the angle measure that we had, not negative, but positive, 13 pi over 6? Isn't that the angle measure that we had up here for our second rotation around on the unit circle? So pi over 6 then came around to 13 pi over 6. It would then come around to 25 pi over 6, etc. Okay? And so whatever you went around on the positive can then be reflected across the x-axis and going around this direction. Okay? And so I just want to try and get in your mind this idea of how coterminal angles revolve around the unit circle infinitely in a positive direction and infinitely in a negative direction. Okay? But the way, in my opinion, the best way to try and answer your sine, cosine, tangent of coterminal angles is to simply take the theta angle there and either add 2 pi or subtract 2 pi. If you're looking at a negative theta angle, you're going to add 2 pi. If you have a positive theta angle, you're going to subtract 2 pi. And remember, you're going to keep subtracting 2 pi or keep adding 2 pi until what? When are you going to stop, Mr. Ryan? You're going to stop when the angle that you come up with is one of these original angles on the unit circle. Okay? And so let's go ahead and take this negative 17, let's do it over here. This negative 17 pi over 4. So we have negative 17 pi over 4, and we're going to add to that 2 pi, right? Well, what is 2 pi? Well, again, we're going to double the denominator. 4 times 2 becomes 8, right? And we're going to put that in the numerator. 8 pi over 4. So 8 divided by 4 is 2. So that's 2 pi. So we're adding 2 pi here. Why are we making it, 8 over 4? Because we need a common denominator, right? Okay, well, negative 17 pi plus 8 pi is negative 9 pi over 4. And now, that's not one of our regular numbers. It's still negative. So once again, we need to add 8 pi over 4. And that gives us negative 1 pi, or just negative pi over 4, right? Okay, which is right here. So it must be this one, right? It must be this point. But just to make sure, let's go ahead and take our negative pi over 4, and we will add 8 pi over 4 one more time. And negative 1 plus 8 is 7. So it's going to be 7 pi over 4 is our coterminal angle. This is the coterminal angle. That is the same thing as negative 17 pi over 4. Therefore, sine of negative 17 pi over 4 is the exact same thing as sine of 7 pi over 4. Cosine of negative 17 pi over 4 is the exact same thing as cosine of 7 pi over 4. So to get sine of negative 17 pi over 4, we're just going to go find sine of 7 pi over 4. Well, here's 7 pi over 4, and sine is the y-coordinate, and that's negative square root of 2 over 2. Therefore, the answer to this one is negative square root of 2 over 2. All right, cosine of negative 17 pi over 4, since this angle is coterminal to 7 pi over 4, we're just going to do cosine of 7 pi over 4, which is the x-coordinate, square root of 2 over 2. All right? And now, to get tangent, we're just going to use the answers to sine and cosine from negative 17 pi over 4. Tangent is sine over cosine. Sine is negative square root of 2 over 2 over cosine, which is square root of 2 over 2. Now, we could cancel the 2's if you want to, and now we have negative square root of 2 over square root of 2. And we know that when we have the same number in the numerator and denominator, that the answer is 1, right? Square root of 2 divided by square root of 2 is 1. It's also negative. So our answer here is negative 1. So tangent of negative 17 pi over 4 is the exact same thing as tangent of 7 pi over 4, which is negative 1. Okay? All right, so we got tangent, negative 1. Now let's go ahead and get cotangent. Well, I'm going to tell you a secret. We know that cotangent is the is the reciprocal. Cotangent is the reciprocal of tangent. And you may or may not know this, but the reciprocal of negative 1 is negative 1, just like the reciprocal of 1 is 1. But let me prove it to you. Cotangent is cosine over sine. Cosine is square root of 2 over 2 divided by negative square root of 2 over 2. Well, look, we have the same thing in the top and the bottom. Square root of 2 over 2 divided by square root of 2 over 2 is 1, because we have the same thing divided by the same thing, right? So the answer is 1, except that we have a positive divided by a negative, which makes it a negative. So cotangent is negative 1. Isn't that interesting? That the cotangent is equal to the tangent in this particular case. That happens sometimes. Don't be afraid to write down the same answer if that same answer is either 1 or negative 1. All right, so now, secant of negative 17 pi over 4 is the same thing as secant of 7 pi over 4. Secant is 1 over cosine. So secant is going to be 1 over square root of 2 over 2. 1 over square root of 2 over 2. And remember, when you have 1 over a fraction, that means the reciprocal, right? And so this is the same thing as we're going to flip over cosine. It becomes 2 over the square root of 2. Rationalize the denominator, multiply by square root of 2 over 2, multiply by square root of 2 over square root of 2. Answer becomes 2 times square root of 2. over square root of 2 times square root of 2 is 2. Oh, look at this. We got a 2 in the numerator, 2 in the denominator. We can cancel. Why? Because it's just multiplication. It's 2 times the square root of 2, and then we're dividing by 2, so we can cancel the 2. Final answer is just this square root of 2 that's sitting all by itself. Well, now it's sitting all by itself. So the answer to secant of negative 17 pi over 4 is square root of 2. Last one here is cosecant of negative 17 pi over 4. It'll be the exact same thing as cosecant of 7 pi over 4 because they are coterminal angles with each other. We proved that right here. They are coterminal to each other. Okay? And so cosecant is 1 over sine, right? So that's going to be 1 over negative square root of 2 over 2. Well, we just got done saying that 1 over a fraction is going to be equal to the reciprocal of that fraction. So this is going to become negative 2 over the square root of 2. Seems like we just did this problem. Yep, we're going to rationalize the denominator. Square root of 2 over the square root of 2. 2 times square root of 2. Now this is negative 2. Negative 2 times square root of 2 is negative 2 square root of 2 over square root of 2 times square root of 2 is 2. The 2's cancel, and all we have left is negative square root of 2. And that is cosecant in this particular one, which is almost the same answer as secant. Now there's a good reason that it's almost the same answer as secant, because cosine and sine are almost the same answer also. Okay? Why is that happening? Oh, because all the over 4s, the sine and the cosine, are the same magnitude. Okay? May not be the same sign, but they're the same magnitude. Okay? That's it. This is all I have for you, coterminal angles. So what you're going to do now is you'll have a whole bunch of problems where, now I may not ask you for all 6 of them. I just may out of nowhere just say, hey, what's the cotangent of 23 pi over 3? And then you're going to have to find the coterminal angle, find out where it matches up, which one of these on the unit circle matches up with 23 pi over 3. And if I asked you for cotangent, then you would then need to identify the sine and the cosine and put the cosine over sine, simplify it, and you'll have your answer. Okay? All right. That's it for unit circle determining the trig functions. Where we're going to go from here now is we're now going to flesh out the trig functions. We're also going to, the very next thing we're going to work on is we're going to work on what are called the inverse functions of the trig functions. Okay? But that's it for the unit circle. Make sure you can produce one just out of memory, and make sure that you are able to, as efficiently as possible, convert your coterminal angle and answer your trig ratio.